So I really enjoy biking on the beach. You get to see all kinds of cool things, and it's just a wonderful way to be out in nature. One of the things that I've learned is that it's better to bike at low tide. There's more exposed beach, and the sand just seems to be packed down a little bit tighter. On the Monterey Bay where I ride, there's a particular section that I wanted to ride, but the water met up with some cliffs. But I thought maybe at low tide, a very, very low tide, I might be able to get through. So this got me thinking about looking up when the predicted tides would be the lowest and at what times of the day, so I could figure out what time to ride. Looking for tide predictions brought me to the NOAA Tides and Currents page. This site has tide predictions for stations around the US, and using the website I found the station for Moss Landing on Monterey Bay and got to this page, which will provide a table of 31 days of tide predictions. So in order to use the script to grab the data from this page, I need to tell the script where to look. To that end, I'll bring up the developer's tools within the Chrome browser, and then find the appropriate structure within that page. And what we see is the table with the data is referred to here as data listing table, so that's what we'll have to look for. Also, it's important to note that the data is brought into the page via JavaScript, and I'll get back to that in a minute. That's an important point. So this brings me to this Python script that will fetch the web page and extract out the predicted tides and times over a 31-day period. In reviewing this script, I'll assume that you know the basics of Python and Python modules. There are many tutorials on these if you're not. However, I'm not a professional coder, and my code is probably needlessly messy, so if there's something confusing about it, feel free to post a question. The modules I needed to download for this script were requests HTML and Beautiful Soup. Results HTML is a module for fetching a web page, and Beautiful Soup then allows you to parse the page or break it up into pieces so that you can get the bits out of it that you want. I'll get back to that in a minute, but this next section defines command line arguments using another module called argparse. Just to review the main arguments quickly, the early and late arguments specify the time of day that I'm interested in. And by default, that's the time between 10 a.m. and 4 p.m. Thus, I only care about the low tides in that time period. The month argument only has two values that it recognizes. The default is current, which means it will fetch the next 31 days of tides. But by specifying next, it will return the tides starting the first day of next month. The low tide level indicates the highest low tide I'm interested in, and since I'm looking for very low tides, it defaults to 0. In other words, I'm really only looking for negative tides. After the arguments, then the action starts. The variable first day is the date of the first day to fetch tides, and it defaults to today. The variable all days then is a time delta of 31 days, and it will simply be added to first day then to get the final day, the last day. These are needed to form the URL that will be sent to go fetch the website. This section does the work of figuring out those specific days based on whether or not we're starting today or the first of next month. This all culminates in the variables date start and date end, which are formatted to be used in creating the URL. Here's the creation of the URL with date start and date end in it. I've hard-coded the station ID that I use, but this is easily changed to the station ID of your choice. This get performs the fetch of the web page, the contents of which are then stored in the response variable. That response then is rendered so that the JavaScript within the page will be executed. This is required for this tides page, but of course not all pages have JavaScript, and so not all need this rendering. Once the JavaScript has been executed, the page should be complete, and the results will still be in the response variable. Then we can use Beautiful Soup to parse the data in the response variable. The results of that parsing is in the variable soup. Within soup, we can look for the table called data listing table, that we identified using Chrome. Once we have the table, we can extract out all the rows of the table. The tr tag starts a new row in HTML, so that's how you identify the rows of the table. After all that, the script simply examines each row looking for low tides and then adds these to the low tides variable. Then there's one more while loop that looks at all the low tides and checks if they are at the right time of day. Remember the early and late from the command line arguments. The ones that fall into the right time range are then added to a string variable called message. At the end, the message variable can be printed out to the screen, and it can also be sent in an email. I invoke this script via a crontab on a Raspberry Pi, and so it just sends me an email once a month. And by the way, the send me mail module is one that I created, and that's also included in the GitHub repository. So I hope this quick video helps someone with their web scraping, but more importantly, I hope someone goes for a walk or a ride on the beach.